it's working, so we don't have to do this. So we're now recording. Perfect. Okay. Okay. All right. Here's some more. This talks about derivative of a constant. It's still c times the derivative. That's really no different than what we're doing. Let's go ahead and practice these, doing the rewrite, the derivative, and the simplify. So how should we rewrite this guy? Okay, and then what's the derivative? And then simplified? Okay, was that okay? We're good? All right, this thing looks a little crazy. What are we going to do? And this is where we will, Jeremy, those fractional exponents will come in on this B part. Okay, so let's try writing this. We have 5/3 x to the what? Negative 2/5. All right, it's negative because it was down here. And whenever you want to change radicals to fractional exponents, numerator is what's in here, denominator is what's out here at the index. Okay? All right, so now what would be the derivative? Negative 2/3, because you multiply that times that, 5's cancel. Negative 2/3, x to the... Okay. And really the rule of thumb, we could put this on the bottom and let it just be fractional exponent, but if your problem has radicals, you usually put your answer back in radicals. If your problem's in fractional, you want to do that. So kind of go with that rule of thumb. So how can we fix this? Okay, yeah. Good job. Good job. All right. F of x equals 6x squared over 7. The quick way to rewrite that, write it like this. Then it's going to remind you what you're doing with that derivative rule. So what do we get then? 12/7 x. That's it? Okay. So that'd be good. We don't have to simplify. All right. Negative 3 square root of x. How am I going to rewrite that one?
X to the 1/2.
Yes, negative 3 x to the 1/2. Derivative would be? Good. And simplifying, remembering that we had radicals to start with.
So it'd be 3 over 2x. So it'd be 2
Square root of x. Okay, good. Good. Okay, what would we rewrite this one? Negative 7x over 3. Okay, negative 7/3 x. And then the derivative would be negative 7/3. Okay? We good? We're kind of good with that power rule. We've done quite a few. Okay. It's better than the definition part, right? Better than the f of x plus h. Okay, the rewrite part or from here to here?
Just all of it.
All of it. Okay. All right. Let's pick one that you want me to go over. First two. Okay. So do you get this rewrite part? That if it's in the bottom, it makes it easier to do that little power rule if we have it all in one line. So if it's x squared here and I want it up at the top, it becomes a negative. So that's 3x to the negative 2. Then this gets multiplied by that. Then you get the negative 6, and you take 1 away from that, you get negative 3. All right, but then we want the answer to be without negative exponents. So you just put it on the bottom and the negative part goes away. Okay? This one, question? Okay. Excuse me, I think it's catching. When you have the fifth root, let me go over here a little bit. When you have the fifth root of x squared, this part is the numerator, sorry. This part is the denominator. So that can be written x to the 2/5. Because it's on the bottom, it's x to the negative 2/5. You don't want to deal with radicals, you want to deal with fractions. They're easier to work with. Okay? Then you multiply this times this. 5's cancel out, you get negative 2/3. X to the, why did this become negative 7/5? Yeah, so you did minus 5/5. So that was minus 7/5. Then this part stays on top. This part's on the bottom. This goes to the bottom, and it's back to radical. Is that a little better? Okay. All right, you'll get a lot of practice. Okay. All right, next rule. Let's see if you can see that. All right, it's a nice one. The derivative of e to the x is e to the x. Okay? It gets a little crazy when you have e to the u, which means you might be taking the derivative of e to the 3x. You get something other than x up there. And the derivative of e to the u is e to the u times the derivative of u. Okay? So we'll get to some of those. It'll be a little different. I don't want you to think it's always just whatever e is, because you do have to do some work sometimes. All right. What will this derivative be? Y prime will be 3e to the x. Okay. Because that constant is there, and it's going to stay there. It's not going to go to 0. It's not being added. Okay, so that's just a simple rule. That'll be okay. Now, product rule. Huge, important. And I don't know that you need to write this down and memorize this. The way I would say it is you do, when you have a product, say x squared times 7x. Now, we could make that 7x cubed. I understand that. But there will be some products that we can't do that with. But just for the sake of that, it's this one times the derivative of this one plus this one times the derivative of the first one. So the first times the derivative of the second plus the second times the derivative of the first. And because you're adding, doesn't matter what order you do it in. It just works that way. In really crazy ones that get to be really complex, I so suggest that you make yourself a road map, because they will not be easy like x squared times 7x. But make a road map where you're saying, oh, it's this thing, and then use ddx or something, some notation that's right, derivative of this plus this times the derivative of that. Then the next line, you're only taking the derivative two places. You know exactly where you're taking the derivative. So you would have x squared times what? 7 plus 7x times 2x. And so you'd have 7x squared plus 14x squared, you know, whatever.
Where did 2x come from?
Derivative of this. And so this would be what? 21x squared? And let's think about, if we went ahead and multiplied that, what would that have been? 7x cubed? And what's the derivative of that? 21x squared? I mean, and you wouldn't want to use the product rule when you can go ahead and multiply them and make it easy on yourself. But there will be many where we can't do that. I did want you to see that you'd get the same thing. So first times the derivative of the second plus second times the derivative of the first. I wouldn't worry about memorizing this. I myself would write first times derivative of the second. I would write it like that. You don't have to have the formal, but whatever works for you.
So first times derivative of the second.
Plus second times derivative of the first. And in fact, when we get to the quotient, that's the way I wrote it for you. When you have a quotient, one thing on top of the other, it's a little more complex and order does matter. Bottom times the derivative of the top minus, and I would always put this in brackets so that you clean that up because all of it gets subtracted, top times the derivative of the bottom. You must start with bottom times derivative of top minus top times derivative of the bottom. If you mess that up, you won't have it right. All over the bottom squared. Okay? Bless you. And those are going to require you to be able to factor. That's where your college algebra or your Math 311 or pre-cal, all of that's going to come back and be really helpful because to clean some of these up, factoring will be important. Okay? All right.
Major factor.
Do what?
It's a major factor.
It's a major factor. I'm going to play like you didn't say that. Okay. Then we are going to talk about other derivatives, higher order derivatives. So we know what y prime is, and then we could have the second derivative be y double prime. You might also see it like this, d squared y dx squared. I don't ever use this one. Don't like it. Y triple prime. Y super n. Never seen that one. I wouldn't worry about any of. This is what you're going to see from me, and from me, and you'll see the ddx. And I use that when I'm in the middle of finding a derivative, and I want to find this small piece. I'm not finding the big total derivative yet, but I want the little piece. So I use that. Okay. So when you're finding higher order, you just keep going till you can't go anymore if you're asked to find all of them. That's what this example says. Find all the derivatives of x cubed plus 4x squared minus 18x plus 12. When you take it the first time, you get 3x squared plus 8x minus 18. Second derivative, 6x plus 8. Third derivative, 6. Fourth derivative, 0. So we went all the way. Okay? It's not so bad when it's just a nice polynomial. It gets bad when you have to find the second, third derivative of a quotient. It's really ugly. Can be. All right, questions about that? How many people have actually had this before? 1, 2, 3, 4, 5, 6, 6 or 7. Okay, so you guys will be helping other people, right?
Try to.
Yeah, you will. All right. Okay, so these are like your homework problems. So let's see if we can. Okay, I don't know why that's not doing that. You probably can't read that. I'm worried about you. Okay. Find the first and second derivatives. I'll write it a little bit bigger so you can see it if you don't have that paper in front of you. Negative 8x to the 7th minus 4. So dy dx is a way to say the first derivative. What's that going to be? And what happens to this? Goes to 0. The derivative of negative 4 is 0. And then they're going to use d2y dx squared. It's saying the derivative of y with respect to x, the second one. So do it again. X to the 5th. Okay, so we're good. Thank you. All right. Everybody okay on that one? All right, on this one. I don't know why this isn't letting me. There we go. There we go. All right, find the first and second derivatives of this. I'll write this here. Y equals 9x to the fourth over 4 minus x plus 3 e to the x.
Can
So,
we deduct it first?
do what?
Can we deduct it first and then take a derivative of that? 36x and then
Where are you getting 36x?
then we times 9 by 4.
Where are you going to multiply 9 by 4? Right here. Right. That 4? It's not raised to the 4. Just the x is raised to the 4. So you can't do that. Yeah. I was trying to figure out what you were asking me. No, can't do that. All right, but I would rewrite it. So I would rewrite it 9/4 x to the 4th minus x plus 3 e to the x. And then I would take the derivative. So what y prime would be what? Minus 1. Just get used to the derivative of plain old x is 1. And the reason is if you have x, that's an understood 1, right? So that 1 goes to the front, 1x, take 1 away, that's x to the 0. Anything to the 0 is 1. So it's just a plain old 1. Not that you have to go through that thought process each time. All right, and what did we say that part is? 3 e to the x. How come the derivative of that isn't a constant, or how come it isn't a constant? Okay, a constant is when you have a number and you do not have any x, like just any digit. But if you have an x, it has an exponent of 1. It is a variable. Okay?
You said like e would be 0 as well.
Well, because e is not a variable. It's a number. E is 2.7 and numbers forever. So it's a number.
How come you rewrote it though?
You don't have to. I like to because, and I wrote it where you couldn't see it right. Sorry. I like to see it where that fraction is out there and the exponent's up there, and it's easier for me to do that. If it is not, if it doesn't help you, you don't have to do it. Yeah. Okay. All right. Let's go to the next one. I don't know why I had these and didn't make them big. Sorry.
Wait, you didn't do y double prime?
Oh my gosh, we had more fun to do. Okay. Sorry. All right.
You wanted to skip it.
I did. I just totally didn't see it. All right. Y double prime. What's that going to be? 27x squared. Now this is a constant. So what's the derivative there? 0. So it's gone. And what do we still have here? Okay. Okay, the rule for e to the x is that it's just e to the x, and the 3 is attached to it, so it's going to stay there. All right, can we move now? We can move now. All right, first and second derivatives of y equals 4x to the negative 3 minus, I would rewrite this. What would we write it as? 7x to the negative 1. That just kind of, for me, makes it a little easier. All right, so what do we have here? Negative 12x to the, and then watch your signs, because this negative 1 times this, we're going to have a plus 7. Okay. All right. Now, let's go ahead and leave it like that. I don't know about the answer. Probably for the answer, I'm going to leave it that way so we can go ahead and find the double prime, because I don't want to rewrite it, and then we'll think about the answers. What's the double prime?
48.
Plus or minus?
Minus.
Minus.
Okay. And so then as you put them in the box, and you may not get this one till you do this one, you're going to have to rewrite it. I think this one will be negative 12 over x to the fourth plus 7 over x squared, probably.
Our homework, it ones like that.
Like this? Yeah, I thought it did. Okay, and then this one would be 48 over x to the fifth plus 42 over x cubed. Oh, here. No?
It's
You
already,
already
you
got
got,
it.
you already picked it. Unless you want us to mark it.
Yeah.
Triple
Yeah.
prime.
Yeah. Triple prime. That could have been good. Okay. Sorry. Thank you. Why? See, I'm taking the derivative again. I'm taking the whole thing again instead of just writing the answer. I'm so sorry. 48 over x to the fifth minus 14 over x cubed. Is that better? Okay. Thank you. All right. Think how much you're learning, catching my mistakes. All right. Okay. All right. You try this one. Rewrite it and let's see what we get. Let's rewrite it first. How should we rewrite that guy?
Two.
And I make my S's like a little cursive S because my others look like 2s or 5s or something weird. So, okay. What do we get for the first derivative?
Do you want that already corrected or just
Just what it is.
negative 2s to the negative 2 plus
Don't you have a negative
Negative a half
1/2?
x to the negative 2.
Plus so negative 5. Would that be right? Okay. And if we had to write it, maybe I can write the answer right over here. What's that going to be?
Negative 1 over 2x squared.
Plus,
32 over 5. That's fine.
okay. All right. And then we've already got this, so let's take the next derivative. What's this going to be? 1/2 times 2 is going to give us 1. So we got s to the negative 3. Right? And then to rewrite that as an answer, like that. Questions? Okay, we're ready for a product rule. So give yourself some room on the paper. Make it a little bit bigger. Well, if it'll stay there. Okay, and big. Okay. All right, so here I'll write it bigger. We've got y equals 4 minus x squared times x cubed minus 4x plus 4. And you could, if you hated the product rule, you could go ahead and multiply these out and then take the derivative. That's some work in itself. But let's go ahead and practice this. So, y prime Okay? I would say top times the derivative of the other one, the second one, sorry. I said top. Plus the second times the derivative of the first one. So you only have to take the derivative here and here. And so you know that right off the bat. All right, so let's write the next line. And you know, if you try to shortcut yourself and not write as many steps, you're going to set yourself up to make a mistake. So be careful with that. All right, so now we've got 4 minus x squared. What's the derivative of this piece?
3x squared
Minus 4. Okay. Plus this piece times the derivative of this, which is negative 2x. Okay. All right, now we're going to go ahead and multiply these, and if it makes it easier for you to think of that as negative x squared plus 4 so that you have it kind of in the same shape as this, then think of it, rewrite it, whatever you need to do. So what are we going to get here? Negative 3x to the 4th, and then 12x squared and minus 16. My math okay? All right, and then we're going to multiply these two together. So we have minus 2x to the 4th, 8x squared, and minus 8x. So double check my arithmetic there. Okay, combining terms. X to the 4th, how many we got? Negative 5. X squared, we got 16 and 8, so 24. Right? Is that right? And then minus 8x and minus 16. I just did it in descending order. So I believe that that's what our y prime is. Okay. Now, it said to do it that way. Then it says find it by multiplying the factors, producing a sum, and then take the derivative. It's worthwhile to practice that. You're going to hopefully get the same answer, so it doesn't matter. If you're sure of your answer, you can just put your answer in twice. But it is worthwhile. What they're saying is go ahead and multiply these out and then take the derivative. See which way you like better. If you're pretty familiar with derivatives, you may want this way or you may want to do that.
I think for me it'd be easier multiplying it than taking the derivative.
For this one, it might be. Yeah. So if you want to do that, you would multiply this out. You'd get a longer polynomial sum and then take the derivative and you'd have those pieces and you should get the same thing. So that's what it's asking you, but your answer should be the same thing here. Okay? I don't care. On the test, if you want to multiply them out and do it, that's fine. There'll be times when you'll have to do the product rule, so it doesn't matter to me what you choose to do. All right, find the derivative of this guy. What is this? This is a quotient. So, see if you can see that. Keep doing that. So y equals 2x minus 5 over 6x plus 1. Starting out with an easy one. We're all linear there, so that's not so bad. And remember, y prime is the bottom times the derivative of the top minus the top times the derivative of the bottom. All over what? the bottom squared. Okay? And this one was easy enough once you get practice that you might not have to write a road map out. But some of the other ones, it will be helpful for you. All right, 6x plus 1 times what? Because this is where we're taking the derivative, here and here. Okay, minus 2x minus 5 times 6. I'm going to keep that in brackets. It's going to save me one day, I know. Okay. So now what do we got? Minus 12x. And this is a minus 30, so it'll be a plus 30. Bless you.
We're not going to change the sign.
Do what?
We're not going to change the sign because we have a negative sign also with bracket.
We are going to change the sign because this is 2x minus 30. And why do I have to, this is 12x minus 30, sorry. And so then this minus affects that, so it'll be minus 12x plus 30. So we are changing it. Okay. Over 6x plus 1 squared. Okay. What happens there? That's gone. So what's our thing here now? Is that what you got? Then I must be right. Okay, good.
You don't work out the bottom?
No, usually you leave it like that. What might happen sometimes is there's a place sometimes where you'll factor, and this 6x plus 1, because it was going to be used up on top, you might be able to factor it out, and then you might be able to mark out 1 or something when you have bigger.
Just a constant.
Do what?
I'm saying if it wasn't just a constant.
Right, and if this had been more complex, it might have worked out that way, but we were canceling everything out. All right. Oh, this one looks great fun. Okay. All right. So you try it. Square roots. For me, I would rewrite the problem. Okay? And for this kind, I would write a road map out. Bottom times derivative of the top, plus top times derivative of the bottom, over the bottom squared, and see where you go. It's going to take a little bit. Oh, and I put this as a plus, sorry. Do what? Of this one? Right there? No. Right here.
Yeah, but then you would minus
It's going to
one.
be 1/2 in front, plus 2D, and then you take 1 away from 1/2.
Yeah, it's something like this. No?
No, because you have 1/2, and you're taking away 2 halves. If you take away 1/2, you get to 0. Take it away another half, where do you go? Negative 1/2. No 3 halves?
Okay.
Yeah, you don't take my word for it on this one? Yeah, try it on your calculator. 0.5 minus 1. Okay. Do what? Scroll up. Oh, problem. Okay. Okay. All right.
Why did you divide it by the? Why did you divide it by the? Okay.
That's part of the formula. It's all over the bottom squared. Oh, that's kind of a crucial part. We have to have that. All right. So, everybody to this part? Or are you finished? You got it. You're done? You're just grinning. What does that mean? Keep going? What do we get when we do this? We have, these are both S's. What's the rule when you have S's and exponents? Are we going to add them? So we have 1/2 S to the 1/2 plus, well, we'll just call it minus. Okay, that's that times that, plus what? You got to multiply this times that. Okay? Everybody good there? Minus, we got the same kind of stuff going on here. So check me on that. All over. Okay. Am I good so far? Oh, good. Thanks. Okay. So what happens to this? It's just 1/2. Running out of room. 1/2 plus, we'll write that here, 5/2 S to the negative 1/2. We got the same thing here, so that's a minus 1/2, and then a plus 1/2 S to the negative 1/2.
Can you just leave it as, all I did was I left the 1/2 on the bottom and the top, and I canceled the S 1/2 from the numerator to the denominator.
You can't because this guy is squared and he's being added. If it were just S to the 1/2, you might do some things, but since you got a bunch of addition and subtraction going on, that doesn't work. Okay? It'd be nice if it could. It did. You got the answer? If you did, that's kind of scary. Okay, so we got this, and what happens here? These are exactly the same, so 5/2 plus 1/2 is 3. Okay, so 3S to the negative 1/2 over S to the 1/2 plus 5 squared. And then what? You look up at the answers and you see that they put things in radical. Okay? And so what do we have?
The square root of S times
3 over square root of S, and I think this is square root of S plus 5 squared. Does that match one of the answers? Okay. Thank goodness. What you should see in this problem, if there are a lot of margin for error. There's a lot of little 1/2s. There's a lot of little exponents that we're adding and subtracting and all of that. For me, it's very important to keep brackets where they are until I'm all cleared with them and I know that I can just go to parentheses or bring it out. You have to watch your signs. It is not the calculus rule that will kill you. It is your algebra and your arithmetic that could kill you. Okay, so you have to be very, very careful. Oh, one more. Are we still writing? Anybody still writing? We're good? Okay. Oh, we have many more. Okay, do we need to do this one? Or you'll be good on your homework. That's the same idea, quotient rule. And if you need to see it worked out, the lecture notes have it worked out. Okay? So I'm not going to do that one. Let's go over these last ones because they have E in them, and some of them are products. So let's look at that. Okay, find the derivative of y equals 8e to the negative x plus e to the 3x. Okay, we don't have a product or anything, we just have two pieces right now. Okay, so you do have to remember when you have e to something other than plain old x, you also have to worry about the derivative of this thing. Okay, so y prime is going to be 8e to the negative x times, what's the derivative of negative x? Okay, plus e to the 3x times the derivative of 3x, which is 3. Okay, so we have negative 8 e to the negative x plus 3 e to the 3x, and I think that's the final answer. Well, the only rule that you're really using is the e to the x, but remember when I said your rule that you got was e to the x, the derivative is e to the x. But what we're seeing here is this is e to the u. That means it's something other than e to the x, and it is equal to e to the u times u prime. That's a rule that you could write. So you write down whatever the original is, and then multiply it by the derivative of that thing there, that exponent. Okay? All right. Let's do this guy. This, we have to recognize, is a product. Okay? That's a product. Oops, right. Okay, so y prime would be x to the 10th times the derivative of e to the x plus e to the x times the derivative of x to the 10th. So we're taking the derivative two different places, here and here. Okay, so we have x to the 10th times what? E to the x plus e to the x times x, 10x, sorry, 10x to the 9th, I think. Okay. And you could maybe leave it x to the 10th, e to the x without the multiplying, plus e to the x, 10, well, usually you write it with a number in front. 10x to the 9th, e to the x. Sometimes you're going to see what's common here. E to the x. So you might see it like that. I don't know. They might accept that. I don't know on the homework. I don't know. But either way would be good. If you multiply what out?
I'm saying if you like say that, yeah.
Okay. Sometimes they want it factored out and sometimes they don't. If you got as far as this, for me, that'd be fine for an answer on a test. It'd be fine. All right. This one has a little bit of work in it. Find the first and second derivatives. So you guys try that. I'm going to leave that right there. The original is y equals x cubed plus 5 over x. And remember, that's bottom times the derivative of the top plus top times the derivative of the bottom, all over the bottom squared. Or, does anybody see what else you could do? Could we rewrite this? Could you rewrite? Could you do that? Is that legal? And would that be easier? What does this become? Is that a whole lot easier than doing the quotient rule? Okay, take the derivative. What do you get? And then it wants you to find the second derivative. And I would work from here because it's easier. Okay? Not so bad. You want to take advantage when you can rewrite things. Have to be careful, but you can do that. Okay. We have one word problem, and then we're good with this section. One word problem. Somebody still writing? Yeah. Lee, you still working? You sure? Okay. I'll just push up a little bit. Maybe a little bigger? Too big? Do what? Okay. All right. Tangent line to the curve y equals 1/3 x cubed minus all this stuff is parallel to this line. So we're parallel to this line at 2 points on the curve. Find the 2 points. Well, what on earth why did they tell me that's parallel to this line? What's that going to help me do? What do we know about parallel lines? What kind of slopes do they have? Same slopes. So let's figure out what the slope of this line is. That means we need to reorganize it so it's in that y equals mx plus b form. So that'd be my first thing. I would write it down here. And I would just reorganize it. And I would divide every piece, just write that like that, by -3. What's the important part that I found? Okay, so that's the slope of the line that I'm going to be worried about, this tangent line to that curve. Okay? All right, so that's the first thing. Now, the tangent line to that curve, the slope of that is also the derivative, right? Well, let's find the derivative of this thing that we're given. Y equals 1/3 x cubed minus 4x squared plus 18x plus 19. What's y prime? Plus 18? Okay. So, we know that the slope of this line is 3, and we also know that this is the slope of the tangent. So, if we set those equal, we'll be able to solve for x, right? Okay, let's do that. So we got x squared minus 8x plus 18 equals 3. Can we solve that just as it is? What do we need to do? We've got to get, when you're solving a quadratic, you need 0 on the right, everything else on the left. So we got that. Does that factor? Yeah. It's convenient. Are we done with this problem? No, we have found two parts of 2 points. We found the x values. How do we find the y values? Plug those into the original. So we need, when x is 5, then we're going to plug it in. What was that original? Y equals 1/3 5 cubed minus 4 times 5 squared plus 18 times 5 plus, is it 19? Yeah. So you can do that on your calculator. What did we get for when x is 5? Leave it in fraction form. I don't want a decimal. 152 over 3? Is that what you said? 125 over 3? Did anybody else get anything different? That's what I got. I like your answer. Try it again. Well, for the 5.
Oh, for the whole thing. I was like,
Well, for this part. When x is 5.
oh, I thought you meant just the first, the 5 cubed times the third.
Oh, no. For the whole thing. Well, I was really wondering where my mistake was, but thank goodness. Okay, I think that's what you get for that one, 152 over 3. And what did you get down here? 46. Okay. So when you would write the answers for this, you'd write it as 2 points, and it would be 3, 46 and 5, 152 over 3. So now when you encounter that problem on your homework, you know what you're supposed to do, right? You find the slope of the parallel line, you find the slope of the tangent, which is the derivative, set them equal, solve for x, and then find out what their corresponding y values are, okay? So I think that does that. Let's see how this record thing.